Hello, in this video we're going to take a look at how graphs can sometimes be misleading and what we can do to kind of help that. So this is based on class activity 15E. So I would encourage you really to look at class activity 15E on your own and then skip through this video and use the parts that you need. So in this first graph here we have Ryan playing with some plastic animals, and he made a pictograph. These are pictures. What's wrong with this? Well, you see here the 3 gorillas and the 2 giraffes are the same height, and the 4 crocodiles are the same height or shorter. So we see that it's really best if each picture is the same size or the same height, really. So if we have a consistent box and we would shrink them all down so each box would be the same size, and in the box we would put a little picture of the alligator, then we could see it. So pictographs, same height is really key. Number 2, what's wrong with this display? Well, the issue here is we really have categories. And this line graph is used for numerical data. Okay, and so instead of using a line graph, we would probably want to use a bar graph to show the categorical data. There's other things you could use as well. But when you connect them with lines, it really makes it seem like something is going down and then it's going up, which it's not really true. There's nothing changing over time. All right. What is misleading about this graph? This graph is misleading. Students often key in on the smoke, and that's maybe part of it. But the main thing I want you to see is this is looking at 2 dimensions. We've got height and width here. So as the height increases, the width increases. And so we just finished area, right? The area of this picture is a lot bigger than the area of this picture, which isn't really fair. We want to compare it on 1 dimension. So if we have a bar here, we need to have the same width bar here. And even that, I made the bar a little bit wider than it should have been. But if you do it like this, you can see that we can compare the height of this one is 3 times, a little more than 3 times as much. But if we compare the area, we could fit a lot of these little things in here. And so when we have 2D, that's not such a good idea. We want to keep it 1-dimensional height here. So that's what I'm showing here with these purple bars. Number 4, students are scooping dried beans out of a bag with a scoop, and then they're counting them and then marking them. And so this teacher asked the student to list out the data. The student listed out the data as 1, 3, 7, 7, 5, and 1. What's wrong with that? It might seem like the student is reading the graph, but the data is actually the number of beans in the scoops. So the first scoop had 27. I don't know about the first one, but we had 1 scoop with 27, 3 scoops with 29, 7 scoops with 30, and so on. 7 scoops with 31, 7 scoops with 32, and 1 scoop with 33. And so, of course, there should be 7 30s here, 7 31s, and 5 32s in this list, but that would be the list of this data. Let's take a look at the next problem here. It's asking is it correct to say a percentage of 8th graders who reported smoking cigarettes daily in the previous 30 days was about twice as high in 96 as it was in 93? And if you look at my lines I've just drawn, you could say it's about twice as much, right? here's 1, here's 2, maybe a little bit less than twice. But this is misleading, and this is something you want to watch for. Notice they started at 6% here and not 0%. So if you read this graph, you can see in 93 it must have been about 8%, where in 96, a little over 10%. You can see that's definitely not a double in the percentage of students there. And so that is what is misleading here. All right, let's take a look at this one. We have children's eating habits, and then ask, would it be appropriate to use a single pie graph as shown here to display this information? At first glance, you might think, well, yeah, sure, this a common thing that teachers tell students is, does this add to 100? And in this case, it does add to 100, and so it seems like we should be able to put them in a circle. Here's the issue. With a pie graph, this needs to be one group divided into categories. And so if you see, if I said, hey, you get to eat one type of food, which type would you like? Everybody in the group would respond. They would have to pick either one of the 4 types, and then this would show you all of the entire group. But if you look closer, that's not what's happening here. This is the percentage of 4 to 6-year-olds that meet the dietary recommendation for the food group. This means 27% meet the recommendation for grains, while 73% do not. So that is one group of 4 to 6-year-olds. Vegetables, there's 16% who meet, and there's 84% who do not meet. Do you see that this 27 and this 16% make it look like it's 2 different parts of the same group, where likely there's some overlap here between these groups. And so this is not a very good graph to use here. It would probably be better to use either 4 different pie graphs. You could have a pie graph here that 27% meet and 73% do not. That would be one way to do it. Or maybe a bar graph would work there, but not one single pie graph. And that concludes this video.